Okay, this post requested the evaluation of this definite integral from 1 to 7 using 3 different rules: trapezoidal, midpoint, Simpsons. This addresses the midpoint rule. Didn't mention that the number of subintervals or partitions was supposed to be 8. And hopefully I've got this function right, that 4 plus x was intended as the denominator for this function. So here, this is the graph of that function. Here we've kind of got dashed blue lines in marking the interval from 1 to 7. And if we're going to have 8 equal subintervals, then each subinterval, if they're going to be of equal length, will be 3/4. B minus A over N. 3/4 or 0.75. Now here I've kind of indicated along the x-axis the intervals that will be created. So if we start at the left-hand endpoint and move one of these widths, 0.75 to the right, we'll be at 1.75, and then I keep adding 0.75, and I should get out here to the 7 at the end. And then we're using the midpoint rule, so we want the midpoint of each of these subintervals. We can find the midpoint by taking the average of each endpoint. So 1 plus 1.75 is 2.75 divided by 2, 1.375. That's what this number is right here. That's the midpoint of the first subinterval. Now the height of that rectangle will be found by plugging this number into this function. So we want to find f of 1.375, and it turns out it's 0.059. If I move to the next midpoint, I'm adding the 1.75, the 2.5, which is 4.25, and dividing by 2. It's the average of the endpoints. So I'll put this 2.125 into this function and get this y value. And then these little as it gets created is the height 0.059 times the width, which is 0.75. Okay, and that's what this shows in this little table over here. You can read this text if you want to see what's going on, but S of x sub I represents the midpoint of the first subinterval. There's the midpoint of the second subinterval. We plug that value into the function to get this function value all the way down to 1, 2, 3, 4, 5, 6, 7, 8. There's 8 subintervals, so 8 midpoints. We're multiplying each of these values in this column by W to get the areas. So those are the areas of each rectangle. We got to add those up. If you have to do this by hand, and write all this down, it's very painstaking. So hopefully you can go to the Desmos graph where all this came from, figure out that this graph will do left hand, right hand, and midpoint Riemann sums. Okay, there you go. Hope that helped. If you have any questions, post a comment.